yeah. He got into natural go there, check
Okay, this one, oh yeah, no,
what was the question? Oh, you mean like career? So I ideas that I have, but I guess I think it's smart. I don't think I don't know what else to say. And I'm looking at it, I'm looking through like, and then I'm just saying, some things that it's gonna seem like the design project, and not just the design.
Hello everyone. I think we have enough people to where we can actually officially get started. So again, thank you and for coming and welcome to our speaker night. As you all know, we're talking about 3D printing and design today. That is not my forte. I don't know anything about it. But so I'm gonna let the expert come and talk about it. Notice we have some mixed people in our midst. You know, this is Baltimore Black Techies, but that does not mean that we only want Black people in here. This space was created for Black people to come here and learn and share resources and thrive. But it's also great to learn from other people from other ethnic groups. And so our speaker today is a white man, and we welcome him. He is a student at UMD University of Maryland College Park, and he works as a lab coordinator at Terrapin Labs. So we're excited to have him here. So welcome.
Hi guys, I'm John. Today I'm going to be going through some basic overview stuff for 3D printing. We're gonna cover a lot of different stuff, so if you guys have any questions along the way, just feel free to speak up and ask me about it. Any kind of questions, fine. I'm pretty familiar with a lot of different stuff in 3D printing, and I'm always happy to share that with you guys. So I'm going to start off with just a basic explanation of what we do at Terrapin Works, and kind of go through that as an introduction to the different things we have there, the different 3D printers, and how that lab setup works. And then I'll move into more of an explanation of how to do some 3D printing. All right, so. First thing, brief history of what Terrapin Works is. So, University of Maryland is a pretty old college as far as Maryland colleges go, and for a long time there's been different research groups on campus that have wanted to do 3D printing kind of stuff. And the trend in the past was that all these different labs would buy their own printers, they'd use them for whatever they wanted, and then they'd stop using them and put them in a closet. And the reason Terrapin Works was created is a bunch of students kind of got together and they said, why don't we take all these machines back out of the closets that people aren't using anymore, put them together, and make them available to everybody, the researchers and students on campus. So it's kind of expanded beyond that. You see, we're actually part of the strategic goals of the university, so we get a lot of money given to the Terraform Works labs to kind of continue offering 3D printing to students. But it's become very, very popular. We've done over 60,000 print hours per year on our different printers. We have over 100 different 3D printers around campus. And it's really become kind of a special thing where students across campus and people outside of the university can come to Terraform Works and we can work with them to do their projects, to print stuff for them, and make this technology available to people that otherwise wouldn't be able to use this themselves. I'll also explain kind of a little bit later on that we have a couple really advanced machines that would cost way too much money for anybody to buy for just themselves to work on. So Terraform Works kind of subsidizes these machines and allows you to print these really cool, complicated machines without having to spend like $100,000 or more to buy a machine like that for yourself. So it's a really cool opportunity to get to work there. So the key audiences that we have working at Terraform Works, the main one obviously is the students. We have thousands of students at the University of Maryland, so we really try and make it as accessible to students as possible. There's also a large entrepreneur audience at the university. There's a pretty successful business school at the University of Maryland, and there's several different organizations focused on helping students create startup businesses. So we do kind of partner up with them. We offer discounted rates for a lot of startups on campus and potentially startups off campus. We can't do it for everybody just because the university subsidizes us, so people on campus get the priority. But we try and help out startups as much as possible because Terraform Works was a startup and we appreciate how hard it is to make it into the business world. And then the researchers on campus are kind of the driving force for what machines we get. Researchers on college campuses really bring in the money for the campus. So if a researcher wants a new machine, they can really convince the college to get a new machine because they're the ones being given different grant monies for their research initiatives. So with that kind of background in mind, I'll start explaining some of the machines that we have at our labs. So some of our main special machines, these ones are some of the top of the line, very advanced machines that you wouldn't see in other places. One of them is the NanoScribe. The NanoScribe is a very interesting machine. It can print objects like you can see in the bottom right down here. That is our mascot, Castillo the turtle. And you can see, well, you can't really see the scale bar in the very bottom, but this is printed smaller than a human hair, this turtle. So this machine is one of the only machines in the country that can print this small. There's only 7 of them in the continental United States. So we're very lucky to have one at the University of Maryland. People will come from all over the East Coast to work with it here. It's a really, really cool machine, and we try and make this accessible to people outside of the university as well. We get requests from neighboring businesses and other universities to use this machine. We also have the ProX. You can see that's the other picture on this slide, the one on the left. So the ProX is one of the newer types of 3D printing that is being talked about a lot nowadays, which is metal 3D printing. So the idea of this is you take a metal powder and it has a very powerful laser and it melts the metal pieces together to give you this final metal part. Now, what's really special about that is it allows you to create things out of metal that you otherwise wouldn't be able to make at all, right? Because the main way to make things out of metal for most applications is you have a CNC machine, which takes a drill bit and kind of carves out the pieces of metal until you're left with your part. With 3D printing, you can get shapes that drill bits just can't reach. So for example, you can see kind of in the back of this one, there's like a cube that looks all speckly. This is actually a custom heat exchanger. So there's all kinds of complicated research being done with heat exchangers, but the end of the idea is this is a cube that's basically like a sponge made out of metal, and it would be impossible to make this with many other techniques, but you can just 3D print it out and have it exactly the way that you designed it right off the bat. So it's a very complicated process. Metal 3D printing in particular is really, really expensive, and it is for any machine, even this one. There's a lot of research being put into making metal 3D printing more accessible to people because it is a really cool technology. But you can see there is research being done at the University of Maryland as well into different stuff you can do with it. We also have the Connex 500. I'll talk more about that one later on, but essentially it's a polyjetting machine. It's different from those other two ones, and it functions a lot like an inkjet printer that you might have at home to print out color sheets of paper. Essentially what it does is it has several different types of material loaded in, and it sprays them out in little droplets, and then goes across with a UV light and solidifies it into a solid object. And since it sprays it out as droplets like that, you can do the same thing that your inkjet printers can do, and you can start with just like 3 different colors of material, magenta, cyan, and yellow, and blend them together and get full color printed objects. You can also take different materials and blend them together to get different material properties. So you can take something that's solid and something that's a little bit flexible and end up with something in between that's solid in some parts, flexible in other parts, and it's all one object printed at one time. So it's a really cool technology. All of these ones are only available as industrial machines. So TerraFormWorks kind of takes them from the industrial side where they're out of reach and not really heard of by people, and brings it back so that people that otherwise wouldn't be able to see these machines are able to print with them and get their parts in them. So we have a couple dedicated labs on campus. We have basically design services and electronics prototyping on campus. We also have kind of our main center, the MakerBot Innovation Center, where we have more than 50 consumer level 3D printers. So these ones aren't as fancy as the other ones, but they still do the job. And for people that are looking to do basic 3D printing prototyping stuff, they can send in their files to these printers and get them printed really fast and at a very low cost. We charge 10 cents per gram of plastic used, and that's basically as low as we can make it. We're constantly losing money on these printers, but that's part of the university. The beauty of the university subsidizing it is they said it's okay for us to lose money, so we just basically charge enough to keep the printers functioning, and then the rest of the cost is kind of taken up by the university. So what this means is that we have a lot of access for 3D printers for students and other people around campus. We've done a lot of kind of networking with different groups that come to the university. There's a lot of different student organizations that kind of make partnerships with us to 3D print stuff. For example, we have women in engineering groups that come to campus each semester, and they have young girls in high school that are interested in the STEM field. We've kind of taught them some 3D design stuff, and then they 3D print out their own designs during the week, and we give that to them for free. So we try and make partnerships with different groups to kind of make 3D printing more known, get people excited about it, show them that it's really easy to use, and make our resources available to people. So the MakerBot Center is really our most accessible one, the lowest cost, most printers. If you're looking for basic 3D printing, that's where to go. So we have a couple different simple use cases, because I hear a lot of people talking about what's the big deal for 3D printing, right? A lot of things you can do, like a lot of times people are talking about you're just printing out trinkets. What can you actually use a 3D printer for? Like, why should I buy one? What is this going to do for my business? Or what is this going to actually be useful for? So I'm going to go through a couple examples, and then I have a couple more things here that I brought with me today to show you guys. So you can see these are 2 examples of some different casings you can do. This is a kind of like circuit breaker organization thing where there's like all kinds of different electronics inside there, and it was 3D printed to kind of isolate different parts of the breaker and cover up some of the wires that you don't want people messing with. We've done some different stuff where like you can do light switch covers for different rooms that screw on so that you don't have people switching off the lights in rooms that you want the lights to stay on all the time for. You can see these ones. These are kind of more electronics casings. This is for like somebody's custom project that they were working on. So one side is hollow. You can kind of pop in some sensors and a circuit board, and then it seals up with the other side, and it's watertight, so you don't have to worry about your electronics getting ruined, anything like that. We've also done some work with, there's this nonprofit group called eNavel. You might have heard about them before. They do 3D printed prosthetic hands for people. So we've done a couple different things for them. They have a lot of different designs. Since we have some of the more advanced machines, we've been able to kind of work with them to do some more of the advanced prosthetics. Well, the one you can see at the top, the black and red one, is the basic hand. So this is printed out of really cheap materials. It's printed really fast, and this makes it very accessible. You can print a whole bunch of them and send them out really quickly and get them into the, like you can deliver them to people really fast and give them to people that otherwise wouldn't be able to have prosthetics. For people that have a little bit more money, you can also start developing some of the more advanced prosthetics. The one you can see kind of holding the others up is printed with the PolyJet Connex machine I was mentioning before. So it has the whole hand is kind of a solid material, and then the joints are flexible, and then you can actually run wires through the middle so that you can have different amounts of flexibility in the fingers and potentially hook up motors to that so that all the fingers can be controlled like a normal hand. So we've done some different work with that. And these are just a handful of examples of how 3D printing can actually be functional in the real world. So that is TerraPrinWorks. If you actually want to learn more about us, potentially get involved and like request different 3D printed stuff with us, our website is terraprinworks.ud.edu. You're always welcome to reach out to us on there. We have all of our different services kind of laid out on our website, and then we have an email system that you can send in an email, and then you'll be directed to somebody that knows how to answer your question. I personally am also starting up a design company and 3D printing service this coming year. So feel free to check out my website as well. It's jmakes3d.com. And basically, I'm going to be helping people that want to have something custom designed for their business or a product, but they don't necessarily have the skills to design it themselves. You can kind of work with me. I'll design it for you, give you the models, print it out for you, do all of that for you, and you don't have to spend all the time investing learning learning how to design and get your own machine to print it. There's like all kinds of different examples of stuff that me and my partner have done on there, like examples of stuff we've designed. But yeah, that's starting up this year. Feel free to check it out. And with that, that's the end of my basic presentation here. The next thing that I want to do is kind of go through a basic workflow of designing something and then preparing it for 3D printing. Before I jump into that, are there any questions right now?
What are the different materials that you use specifically for like 3D printing? Like are they, where would you, I guess, buy those? And yeah, what kind of way to buy those?
So there's a couple different kinds of plastic that are typically used for 3D printing. The standard one that's the cheapest and easiest to use is called PLA plastic. It's kind of marketed as being biodegradable. And it's just really simple to print with, but the caveat is it melts at a really low temperature. So if you want something that's going to be outside or in your car or really functional, PLA might not be the best one. Another one that's tossed around a lot is called ABS. ABS isn't actually that great for 3D printing. It's kind of difficult to use. The main thing is it has a higher melting point than PLA, so it can survive in cars and outdoors. There's kind of a middle ground between them called PETG, PETG. That one is a little bit higher temperature resistant than PLA, a little bit lower than ABS, but also very easy to print. So that one's really ideal for your mechanical parts, and unless you need something that's like really high temperature, then it's kind of your best bet. All of them are pretty similar in cost. It's typically in the range of $20 to $40 for a 1 kilogram spool of plastic. And you can buy these online from Amazon, or there's a bunch of different websites that only sell 3D printing stuff.
Biomolecular tissue.
So
I'm thinking like 3D printer development.
yeah, so there's a couple different things going on with bio 3D printing specifically. For the most part, bioprinters, how they're functioning with today's technology is you have a syringe that you load whatever you want in, and then it kind of puts it out as a gel layer by layer. The nanoscale one in particular is really difficult to use for bio stuff because when you get that small, you have all kinds of really awful problems to deal with, like
Physics.
yeah, physics starts becoming a really big issue. One bio thing in particular that we were actually working on today is there's a group at the Children's Hospital in DC. They're printing with silk fibers made by spiders. But in order to do that, you have to custom make the like material to print with and like mix the silk together with some material that'll like harden. And in order to keep it usable, it has to be like negative 40 degrees Celsius. You have to like store it in a liquid nitrogen cylinder, and they drive it up from DC in the cylinder and then take it out. They've got like 5 minutes to use it before it evaporates. So there's research being done, but it's still really tricky because anything that small is just a huge pain to try and figure out what's gonna happen, because you never really can know exactly what's gonna happen until you give it a shot.
I'm actually a mentor at the Demon Center.
Yeah.
There, so I work with a number of startups, but on average, how long does it take to produce a prototype? And the reason I'm asking is because I'm a biological tech organization, so we definitely will be using stuff like this.
Yeah, so it depends exactly what you're going for, right? Basically, we have two different mindsets when consulting somebody on a project. If you come in with a very strong idea of what you want, like you already have kind of sketches laid out of what you're envisioning this to be, you kind of have an idea of how you want it to work. If you have put in the legwork initially to basically know what you want out of it and you just want us to make it, that's a pretty quick turnaround. That can usually be done in like a week, 2 weeks. If you just have a concept idea, but you don't really know how it would function. For example, something like that is somebody came to us about a year ago and said, I'd really like to make a smart crochet hook. So when I'm crocheting, it'll tell me stuff like what stitch I'm on, how many more stitches I have to go, when I have to do a different technique, stuff like that. That's all that they gave us. They said, that's what I want. You figure out how to do the rest. Something like that is much more nebulous, and that is on the order of like several months to a year to kind of really work through it. It can go faster, but it can take longer. The university design team is typically a little bit slower because it's all student run, and so, you know, students have their school schedule as most important, and they're working part-time at TerraformWorks. If you are really in a crunch time situation and you really want your design to be updated really fast, that's why freelance businesses like my startup would be helpful, because we're dedicating most of our time towards design work. So that's kind of the trade-off. If you have a longer time frame, TerraformWorks is usually cheaper, and you can kind of work with them as long as you don't have like any set deadline.
I was just wondering, because you said the women in engineering running
Yes.
theirs, and they took something home. So I was wondering what was actually printed when they could take it home that fast.
So I taught a basic lesson in 3D design to them on the Monday of a week, and we have a tutorial set up for anybody who's new to learning 3D modeling on our staff that we take them through. So it's basically a phone holder where it's like a small plate that plugs into the outlet, and then it's like a little shelf. So your plug actually holds it against the wall, and then you can set your phone on the shelf and just leave it there against the wall while it's charging. So it's really simple, and then we like have them put their initials on the side. And so it's only like this really small thing, pretty fast to design, and then we're able to print like 20, 30 of them in 2 days because they're really small and easy to print. Any other questions?
Can you talk about like cybersecurity, since you mentioned dealing with a lot of entrepreneurs? How does like TerraformWorks protect like intellectual property from these entrepreneurs and products, from various entrepreneurs?
Definitely. So TerraformWorks in particular, it's difficult because university is our main sponsor, and so any legal contract has to go through the university lawyers, and that's very hard because they are very hard to like get to do paperwork. But essentially we have a 1-year NDA agreement that we can sign with anybody that is willing to agree to the terms that we've already laid out. It took us like 4 years to get that one approved so we can just hand it out to people. So if that one's not good enough, it's gonna be very difficult to get a different one, but we do have a 1-year NDA agreement that we can offer to people that have them signed. And then what that basically means is that for 1 year, anybody working on your project in Terrapin Works is not allowed to discuss anything specific that you want to keep private for your intellectual property, and they're not allowed to do any personal research or development for their own gain or business on your design. They can only work on it for you. Yeah.
Also about security, print, have you ever tried using either the nano one or the PL plastic one? Have you tried like printing fingerprints or like contact lenses or like
So-
face to face?
We've done some interesting stuff there. Fingerprints has been an issue in the past. Since fingerprints are actually one of the bigger small features, right? With anything that is resin capable, you can get a pretty accurate fingerprint pretty easily, actually. It's not that hard to make a 3D model of it. I still wouldn't worry about it necessarily being a huge risk because resin printers aren't super available right now. Most of the ones that are cheap aren't as reliable. You'd need a more reliable one to really guarantee that it's gonna work. But it is a concern. Like, I mean, it has been done. People have proved it. Every time a new phone comes out with a fingerprint reader, people try and get into it with different methods of making 3D fingerprints. So that's definitely something that's been experimented with. I'll go into more of the bio aspects of 3D printing as well, some of the other stuff you were talking about. There's been some research specifically done on organs and contact lenses, stuff like that.
Yeah, so what's the scale of like you can make a object? Like I'm thinking, I've heard like in the car industry, they're thinking like maybe 3D printing for some of the smaller molding. I guess talk about what's the scale that you can build out.
So there's several different scales, right? Obviously, we start at the very bottom with the nanoscale one. That one, the size range is like microns, which are very, very small, up to, I believe, like 1 millimeter is its maximum size. Yeah, so like it's real small.
Right.
The next size up is consumer grade 3D printers. So these are your desktop size ones that can fit on a table like this, and you have a couple inches of build area. You then start to get into the more low-end industrial machines, which you have several feet of build area. These ones are gonna cost you between 10,000 to 50 grand. And those ones, basically, as you start scaling up 3D printers, you run into a lot of trouble of getting things to stick because it gets so big that a draft from your room will ruin the whole thing. So you have to build very specific and controlled environments for big 3D printers to work. But it can really scale all the way up depending on how much money you want to throw at it. Like just recently, the largest 3D printed object ever printed was done, and it was this massive I-beam for a bridge that they did just to see if they could do it. And it was like bigger than this whole room, and it was all 3D printed. So the technology works at pretty much any scale you want. It's just much more expensive to make it big. Right? So I'm gonna start the demonstration, and then you guys can think if there's any questions that kind of come up as I start going through this. So there's basically 2 parts to actually getting stuff 3D printed, right? The first thing that you want to do is get your 3D model. So there's 2 avenues to get a 3D model. You can either download one that somebody else has already made and then just send it straight to the printer, or make it yourself. Making it yourself is going to be more tailored to whatever application you have. So this is where you're going to see a lot of design work and a lot of functional 3D print designs, because you're going to have some very specific problem that you want to solve. You'll put in the work to make a model that specifically solves that problem, and then you can print it. So I'll go through the basic design concept of that phone holder thing that I was talking about. So we can just go through making that really fast, and then you'll see the basic idea. So,
And John, just for the people to know, what program are you using to create that design?
yes, so I'm using a program called Fusion 360. It's by the company Autodesk, and I really like this program because It is free for anybody making less than $100,000 using it. The demo thing is very prominent on the website. It's a little bit, you have to click around a little bit more to actually get to the full download for free, but it is there. You just gotta do a little bit of digging to find it. And then what's really nice is it's a cloud-based program, so you don't have to have a really powerful computer to run it. You just have to have a couple gigabytes of space on your computer, and then most of the work will be done in the cloud. It can run on Mac and Windows, so you don't have to worry about having the wrong system type. And whenever you log into a computer that has it installed, you just log into your account and all your files will show up for you. You don't have to bring them around on a flash drive or anything. They're just stored for you online. So it's a really nice and easy tool to learn and just kind of get accustomed to. For reference, a lot of commercial CAD softwares, computer-aided design, are going to cost you several $1,000s for a license for the newest version each year, and they don't give you any kind of like free upgrade. You have to pay $1,000 or like usually $3,000 per year for the newest version. So I really like that Fusion is free. So first things first, the basic idea is all 3D modeling in CAD software is done by making sketches. So I selected a flat plane, and now I'm drawing a shape on it. So this is going to be the back plate of whatever, of the actual phone holder. And I can use this basic shape to kind of build things out. So you'll see I started with this overall rectangle, and now I put in these 2 smaller rectangles. The 2 smaller ones are gonna be the holes for the outlet plug to go through and hold it against the wall. So you'll see right now they're kind of just haphazardly in there. The next most important thing besides sketches is adding dimensions. So the dimensions are the actual sizes that you're using on your parts, and it's going to tell it how big you want everything to be and where on the stuff that you want it to be. So for this, let's make it 7. We're not actually going to print this, so it can be a little bit arbitrary. 7 and 12, sure. And then you see up here, we have these constraints. Constraints are kind of similar to dimensions, but you don't have to type any numbers. Basically, constraints allow you to use geometry to do some of the work for you. So, for example, we want these rectangles to be the same. I made this one 7 and 12. I want to say that this side length is the same as this one, so I actually have this button here, equals. And I can just click on this line, and now it's going to make them exactly the same. So you can use these different constraints to kind of speed up your workflow and not have to type as many numbers in every time. Now I'll go back to dimension, and I can kind of add a little bit more in here. So I'm just spacing things out and getting it ready for like the final creation of the geometry. So like I said, all these numbers are kind of arbitrary. If you're actually designing something for an actual product, a very useful tool to have is calipers. So they make digital calipers that you can measure very, very small distances, like less than a millimeter lengths. The digital ones are available for like $20 on Amazon. These are a really, really useful tool. You can measure circles very accurately with them, which is very hard to do with something like a ruler, and you get very precise dimensions. So I would recommend anybody who's serious about learning design get a set of digital calipers.
So it's a physical device that you use to measure what you're actually designing on your laptop?
It's if you're like designing, say, something that's supposed to fit around your phone, you'd use it to measure your phone. So it's to get the dimensions that you'd want to put in here. So for example, on this one, maybe I don't know exactly how wide the outlet plug metal strips are. So I want to measure exactly how the width. It's such a thin thing that holding it up to a ruler would be kind of difficult to get an exact number, but you can use your digital calipers, and it's basically 2 jaws that slide together, and it'll tell you the exact distance between them, and you can use that precisely in your drawings. You'll see we can use another constraint here. Right now, you'll notice these 2 rectangles are kind of in random heights from each other. So what we can do is, where is it? they move these around every now and then. Collinear is from the drop down here. So collinear will tell us that we want two lines to be along the same path. So for example, this top line and this other top line, if I click both of them, now they'll stay aligned next to each other. And if I try and click and drag this one around, you'll see they just stay together. So now what we can do is add in some final dimensions. You can see as I start adding in more and more dimensions, the lines turn from blue to black. You'll notice these ones are blue, these outer ones are black. Black lines mean that it's fully dimensioned and it's not going to move anymore. Your goal is every sketch you make, you want all the lines to become black, because if you have any blue lines, there's a chance that if you change your design later on, it's going to move around unexpectedly and you're going to have to go back and fix it. Whereas if you have all the lines black, then when you change something, you know that everything's going to stay exactly where you want it to stay and not shift around unexpectedly. So the outside, we just need these two dimensions to tell it how big it is. These ones, we have it telling it how big it is, but we need to tell it where these need to be inside of this square. So what we can do is go from this bottom corner to the bottom edge and make that 10, and then do the same thing here. I'll also show you something. When I click this dimension, it pops up and allows me to type it in. I also have the option to click on another dimension. If I click on that and then hit enter, it'll make it the same amount as that dimension. And then if I wanted to, I could change this one to 12, and it'll change the other one automatically. So it is linked to this one now. So you can do that very easily and kind of share dimensions and not have to type out the same one every time if you have it repeating over and over again. So now you'll notice all the lines on this sketch are black, so we're ready to finish it. So we go up to the top and hit finish sketch, and it'll kind of move back out, get rid of the grid background, and we can rotate it around and look at it in 3D. So what we're gonna do now is called extrude. Extrude is the primary thing that you use when 3D modeling. Basically, it takes a 2D shape and pulls it out into 3D. So I'll show you that now. You just click here and you'll notice it'll outline what shape you want. I could also hover over either of these small rectangles inside and it could make those into 3D. But we want those to be holes, so we're not going to click on those. So I'll just click on this outside, it'll turn blue. Everything blue will be made into a 3D shape. So now that it's selected, you see we have the same thing down here as when we were typing dimensions. This tells you how big you want to make it. So we'll make this, for example, 1 millimeter and hit OK. And now we have this small flat plate that was made into 3D. So it's very thin, but it is 3D now. So what we can do next is just make another sketch. So you can see I have this cube up here. It's labeled. It's a little hard maybe to see on here, but it's over in the top right corner. And it's labeled on each side of the cube with top, left, front, right, anything like that. So if I click on the face of the cube that says top, it'll bring me to the top view of my object, and then I can move it around and take a look at it. So if I want to look at exactly the side here, I can rotate and click on the cube and click on left, and it's going to rotate around to the side for me. And now what we can do is make a new sketch. So to make a sketch, it has to be on a flat surface. When you start off a part, you typically use one of the origin planes. So these are going to be related to the X, Y, and Z axes. Wherever they intersect, it's going to make a plane. So you can start off on one of those for your first sketches. Later sketches, you can still use those, but you can also use anything flat that you've made now. So since this is all rectangles pretty much, you'll notice that the side here is actually flat as well. So if I click on it, you'll see it'll turn blue. And now I can go up to this button up here and hit create sketch. And now it's going to bring back the grid, and we're making a sketch in the same plane as that side of the rectangle. So what we can do now is draw out another rectangle for kind of a shelf. And then we'll add a little lip up here to hold your phone. And you'll notice when I start closing shapes, it goes from being just an open white background to having this closed kind of peach color. That's what you want to look for. When it fills in like that, you know that the shape is fully closed. So for example, if I pull this point off, I can delete this constraint and pull this point off, and now you'll see it's open. So when you're in really close, it's obvious that this isn't fully closed and it won't be able to make into a 3D shape. But when you're zoomed out like this, it might not be as clear, right? Because the point looks like it's on top of stuff. So that's why it does the shading, is it allows you to really focus in and make you confident that your shape is fully closed in and will be able to be made into 3D. So we can always go back, grab this point and drag it over to line, and then it will close it back up. So since this is kind of a brief demonstration, we don't really need to go into adding dimensions to these things. It's the same process as before, where you just hit the dimension tool and then click on the line you want to add a dimension to and give it a number, and then it'll adjust for that. You can also click and drag stuff around to kind of play with the shapes a little bit more organically. So we'll do something like that. And now I can hit finish. Notice these stay blue, right? That's what we want to avoid. We're kind of speeding along through this to get through it. But if you're doing proper design, you don't want that to happen. Because see, if I click and drag on this out here by accident, trying to move stuff around, this changed. And I don't know exactly how that changed. I don't know what the new dimensions are. That's why you don't want anything to be blue. Because if you're out here moving stuff around, you're clicking on stuff, trying to make sketches, and you accidentally drag a blue shape, you're not going to realize that it changed. Maybe it only changed like a little bit, like 1 millimeter. And you didn't see it, but then when you print it out, it's not right anymore. That's why you want to make all your dimensions fully in there, make all your lines black. So we can go ahead and just kind of drag that back a little bit. And then we can go and do another extrude here. So we can select both of these shapes and flip the direction. And I can actually do, so before I just told it exactly how far I wanted it to go. I can also do this thing where I say, instead of distance, I can tell it to a certain thing. So if I hit 2, I can click this other surface over here. I think it's being difficult. There we go. All right, so see, I hit 2, and now it goes all the way along, and you don't have to remember exactly the length of that side. You just tell it, I want it to go the whole side, and it does it. So at this point, you'll see we have basically the holes for the plug to go through. We have a little shelf on the top for the phone to rest on. What we can do now is add in a sidewall here to kind of brace it so that doesn't just snap right off as soon as you put your phone on. So what we'll do is click on the side here again to do another sketch, hit sketch, and now we're back into the sketch view. And what we can do is just add in a line from here to here. And you'll see, since we have the other shapes around here, we already have the lines formed by the actual object. You don't have to add any other lines in, it automatically shades it in for us. So now we have our triangle, we can use that as like a little brace for it, and we can just finish the sketch right away. And just do another extrude and pull this out. We can just kind of freehand this a little bit, do it 2 millimeters. And now we have something that's starting to come together a little bit, right? We have a shelf on the top, holes for the plugs, a little thing on the side to brace it. This is your basic idea for something that could be 3D printed to hold up a cell phone and be held up by your plug. So let's call this done. What we're gonna do now is, I can always hit save and name this test phone holder. And now you'll see I can choose the location that I want. So by default, it's going to save to my test prints location. I like to have a folder called test prints, where anything that I'm not sure about the actual design, or if I'm just experimenting with different design tools, I save it there, print it out, see how it turns out, and then you can make separate projects for anything that you're designing for a specific purpose. And you can save all your different versions as you change your design in that folder. So we can go ahead and save it in test prints and hit save. And now we're ready to go and save this into a 3D printable file. So what I can do is right click on the name test phone holder up here, and then I'll do save as STL. So this is important for 3D printing. The main file type that people look for is a .stl file. There's a couple others that you can use, but that's kind of the standard right now. So I right click and hit save as STL. It's gonna bring up a little menu to ask what I wanna do. The most important thing to check here is your refinement level. You always wanna set the refinement level to high. If it's at medium or low, what that's gonna do is decrease the number of shapes in it to make it a smaller file, but it's going to also make your file less detailed. So for example, if you have a circular hole, if you do low refinement, it's going to change the circles from actual circles into something like a hexagon. So it saves on file size, but it gets rid of your details. So you always want to do refinement high so that anything that's supposed to be circular stays circular. You don't lose details that you're expecting to have. So once you make sure that's there, you just hit OK, and it's going to give you a pop-up asking you where you want to save it. And we can just save it here, that's fine. And now we're all set. So before we close out of this, you just want to make sure everything is saved. You'll notice specifically in Fusion at the top, there's the name of your file. If I make some kind of change, like if I started a new sketch on here, you'll notice there's a small asterisk at the top right here. Anytime there's an asterisk, that means you haven't saved. So you always want to make sure you save one last time before you go and close your files out. In Fusion specifically, there's this nice feature. Every time you save, this window pops up asking you for a version description. So whenever you're working on something and you're making a bunch of revisions to it, it's always good to put a brief description down saying what you changed since the last time you saved. So that way you can always go back, look through all your versions and say, okay, this one didn't work, but my version where I had X there, that one worked really well. So you can go back and look through all your descriptions, find the one that you said worked really well, and then restore back to that and save that file again. So it's always good to name something in your version description. So at this point, we're ready to go to the 3D printing software. So I can go ahead and open it from the bottom. This is one specifically for the 3D printer that I own. There's a lot of open source ones. This software is also free. It's called Prusa Slicer. It works with most types of 3D printers that you could buy. You just have to enter in the settings for what your printer has and it'll just work. So all I have to do to set it up is I hit this add button up in the top left, and then I can choose the file. So I remember I saved it in this 3D objects folder, and then it's right here, test phone holder. I'll hit open and it's going to load it in. So in the software, you'll see it kind of lays it down. This background that it has here is actually the surface of the printer. So you can see it shows you the physical size restriction on how big you can get it, and you can choose exactly where on the printer you want it to be. You can add in other files and position them around. Yeah.
And what program is this?
This is called Prusa Slicer, Prusa Slicer. So yeah, at this point I can rotate it, I can move it around. I have these tools on the side to scale it if I want it to be a bigger size. Typically you're not going to scale things up. What you're going to do is if you have a really big part that you want to print out as just a test to see how it's working, you take the really big part and scale it much smaller, print out as a small scale, see how it's working, and then you can eventually print it at full size when you know all of your features are going to work properly. But you could always scale it up if you need to. We have the rotate option if we wanted to, for example, rotate this around just so it's facing the other direction. You can do stuff like that. This program in particular also has this option called lay flat or place on face. So if I click on this object and then click on this, it kind of brings up these shapes that it thinks you might want to be flat against this build surface here. So for example, I could click on this one over here and then it's going to flip it around for me and print it this way. Something to keep in mind specifically with 3D printing is your object is weakest in the direction that it lays down plastic. So how basic 3D printers work is it melts plastic and it puts it down one layer at a time, stacks the next layer up. So think about it is a bunch of layers of plastic all stacked on top of each other. So if you're trying to rip something apart, it's going to be easiest to rip them apart in the direction that they were stacked. If you're pushing it on the side, it's a lot stronger. So you want to keep that in mind when you're printing something. So if we're taking a look at this one, for example, the weight of the object is going to be on the top of this shelf, right? The phone is going to be pressing down on the surface up here. So if we, for example, had it printed with this big flat surface on the print bed like it was when it originally came in, the weakest orientation would be with the phone on the top there, right? Because if we have it like that, we just put it back how it was, the layers stack up this way, right? They stack going this way. So there's a bunch of layers this way. And so, well, it wouldn't be the entirely weakest way that way, but you're going to have a lot of force pressing against those layers along the lines where they're stacked. So it's going to be easier to break it off that way. So you always want to keep in mind which direction layers are going. And then you can kind of decide how you're going to set it up. So now I just hit slice, and at this point, it's ready to send to the 3D printer, ready to go. Yeah.
Can you show how you would like change the scale? Because you mentioned you could do that.
Yeah, so if I go back out here, this button right here is the scale button. So I click on the one I want to change, hit scale, and now I have these sliders that I can directly change. If I click on this one, it changes the whole scale. If I drag one of these, it changes in just one dimension. You also have these options down here where the scale factors tell you exactly what's going on. So I could change the scale back to 100% and it'll change right there. So you have a couple different options for scaling things. All right, so that's it for the basic walkthrough. I have some things that I brought with me to show you some different examples of 3D printing. And any questions that people have, I'll try and stick around a little bit and we can talk more about 3D printing. I just have a couple things here to kind of show off. So I wanted to show a couple different options for 3D printing. Starting off with the stuff that you can afford for an in-house one, and then working our way up to more expensive advanced ones. So the one that I personally have is by Prusa. It's by the same people that made that software. It costs a couple $100 to build it yourself. You're paying a little bit more money than the cheapest 3D printers, but you're also paying for the security knowing that it's not going to catch on fire. The really, really cheap 3D printers will catch on fire. So the Prusa is pretty much the cheapest one you can get that's not going to do that. So you can see with that, I've been able to print out some, these are some like basic little, like nice looking things for like desks.
Can we pass this around? Just
Yeah, definitely.
don't
So,
break it, guys.
you can get some really nice details on stuff. You can use different materials. This one's like a shiny plastic that looks almost metal-like. My one in particular, there's a modification you can do to it to make it print multiple colors. So you can see like this one, this is a full color like Goku from Dragon Ball statue.
Oh.
So you can do all kinds of cool stuff there.
Okay, pass.
You can also do some functional stuff. So these are all just like desktop showpieces. This is an example of a functional thing. We had somebody come in with an audio control panel, and there was a bunch of dials on it that they didn't want people to mess with because changing those would be a huge pain to reset them. So they asked us to make a special cover that would cover up all of the buttons that people aren't allowed to touch and allow holes to go through that people can press the buttons they are allowed to touch with like a pencil or something. So we designed it up, printed it out, and they have one of these covers that they can just pop right onto their audio panel and it's good to go. You can also see some examples. This is a air vent kind of thing that people were designing. You can do different custom air ducts. People have done stuff for exhaust systems for cars. We have a race car design club on campus that makes a custom race car each year, so they have printed out stuff like that. This is an example of something that I was using Fusion 360 for. So this is a padlock design that I designed out and then 3D printed as kind of just a test of the mechanism. So you can get some pretty complex mechanical stuff done. And as long as you design it right, it'll all work after you 3D printed it. So that's kind of your basic 3D printers that are melting plastic. Some of the other stuff that you can do is, this is a 3D printer that adds in reinforcement material. So it still melts the plastic and puts it down layer by layer, but you can see inside of it, there is Kevlar. So this makes it much, much stronger. If you try and squeeze on the sides here, you're gonna feel it's very, very strong. Like, I wouldn't be able to break this probably just with my hands. It's very stiff. So you can use this to kind of get metal-like parts without paying for all the money that it takes to make something out of metal. You can also do stuff like this resin printed part. So this is printed on a printer that has a lot more detail and it comes out watertight. So if you're doing something with electronics, specifically if you have electronics that are going to be outside or underwater where it's very important they don't get wet or don't get dusty, you print it on this, it'll close it up and you won't have anything coming in and it'll be very high detail. So you can take a look at that one. Yeah.
So you mentioned one of the parts has Kevlar inside of it.
Yes.
How do you switch between materials as you're printing?
That one in particular has two separate nozzles right next to each other. One of them does plastic, one of them does the Kevlar, and it just switches on its own. Yeah, it's one continuous piece of Kevlar all wound up, and so it'll print the plastic, and then it has the hot Kevlar, and it just puts it in. The Kevlar doesn't actually melt, it's just hot enough to melt the plastic around it and hold it in place. We also have the Connex type printer that I was talking about before that's like the inkjet printer. So we've been doing some medical research with people on campus. You can see this is an example. This is the bronchial tubes of an actual person. You can see it's about life size to me.
Wow.
So this is somebody's larynx and stuff back here, their esophagus and airway, and then all the way down into their bronchial system for their lungs. So this was taken directly from somebody's MRI scan, and then they converted it into a 3D model and printed it out, and they printed it on the Connex, which, like I mentioned, you can mix materials on it. So they mixed a solid material and a flexible material, so you can see it actually bends a little bit.
Wow.
And this is actually about the actual consistency of this organ in your body. So I'll pass this one around. Be a little bit gentle with this one. It's bendy, but it's not super bendy, so don't like try and like really twist it around. But we've been doing some stuff with medical research like that. This is another example. This is back to the basic 3D printer. I printed this on my one at home, and this is a really cool process. There's people doing research at Children's National right now. This is actually my brain. They gave me an MRI, and then I was able to take the MRI, convert it into a 3D file, print out my own brain. So you can do really cool representations with 3D printing. There's actually companies right now where if you're like donating your kidney, they'll take a scan of your body and 3D print the kidney for doctors, and they'll give them the model of the kidney so they can practice the surgery before they go into surgery and know exactly how your kidney is going to work before they go in with your kidney and the actual person that needs an implant.
So they can do a scan of your entire body in theory, and then when it's time to practice for surgery or something like that, they can probably just image that exact organ, and then that's how, I saw it on TV the other day where they can just image that exact organ, and they practice on that before they actually do the surgery.
Yeah, exactly. So, that's most of the 3D printing stuff. I have like a handful of other stuff if anybody's interested in coming to see it afterwards. We're getting close to the end of time, but I'd like to field any questions before we fully run out of time. Anyone have any questions for me right now? Yeah.
You said it's all layer by layer.
Yes.
Are they trying to do maybe a different process so you don't necessarily have those before you do it?
So there's one process in particular that's been kind of researched recently. It's called 3D printing. And instead of putting it down layer by layer, what you have is a cylinder filled with some kind of material that hardens when a certain type of light is shined at it. And they spin the cylinder around, and they have a projector that shines the light in from the side, just spins around really fast, and hardens it as it goes. So it's still kind of hardening layer by layer, but since it's spinning around so fast, it's all kind of solidifying at once. And so you don't have the same weak points that you have when you do it physically layer by layer. So that one's a really cool technology. There's a lot of research being done on it, but it's still really early on in the research process. So there's not going to be a consumer version of that printer for probably another decade at least. Any other questions? Yeah.
In a house, just in a house.
So I haven't personally seen a house printer. The main drawback with those ones is the main technology for printing a house is using concrete, right? It's the same basic technology as any printer that uses plastic, but you need basically a large amount of concrete. So it is possible to do printed houses, but they're actually not a lot cheaper than making houses with other materials because you're paying so much money for all the physical concrete. You need a lot of concrete to be able to print it out. So it's a cool concept, but right now, with the way concrete is currently made, it's really not feasible yet. Anyone else?
Well, the design, the 3D design that you were doing, so that was kind of the first step. You have to create your 3D design.
Yes.
That looks like that's probably where most people do not have the experience. And so Terrapin Labs, do you guys actually help do some of those designs?
Yes,
Okay.
so that comes into the play of a couple of different avenues, right? During the school semesters, we have weekly CAD coaching workshops. So me and a couple other people that are experienced with 3D modeling sit in a computer lab for 2 hours every week, and anybody, student or off-campus people, anyone is allowed to come in and ask us for help, and we'll train them on whatever 3D modeling program they want, whether it be an actual CAD program or something that does things with surfaces, like there's a couple of like Blender is an open source one that you can use for like animation purposes. Anything like that, we'll have somebody who knows how to use it and we'll show you how to do it and kind of walk you through some examples. So you can get training at that, or if you don't want to learn it yourself, you just want to have somebody else who already knows how to do it for you. You have the Terrapin Works design team or companies like myself where you just give the idea to us, we'll do the design work for you, you pay us, we give you all the files, all the printed objects, it's all yours. You don't have to worry about designing it yourself, it's just done for you. So there's two different options there, either committing the time to learn it or paying somebody else to just do the legwork for you.
I've experienced like working with like similar 3D like on Fire.
Yeah.
Can I like take those models and say that as STLs and use those for 3D printing, or actually
You can definitely use those for 3D printing. When you make stuff with Blender or Maya, something where you're modeling, not like Fusion, where you're kind of like dragging meshes around and expanding them freeform, you run into a problem where a lot of times models that you make have overlapping surfaces that are kind of crossing into each other, and 3D printers don't like that. So what you're going to want to do is bring them into a different program and fix them first. What I recommend is this free program called Mesh Mixer. You can just bring it into Mesh Mixer. There's a command there called Make Solid. You turn all the parameters that pop up when you are in Mesh Mixer and hit Make Solid. There's like a bunch of sliders. Just slide them all the way to the right, max quality, hit Make Solid. And what that's going to do is basically take the outside surface of whatever your part is and make a new file that's just the outside, and it gets rid of all the stuff intersecting on the inside for you. It just does that for you. You don't have to worry about fixing it yourself.
so it's like my
Pretty much, yeah.
But you could use something like Maya.
Definitely, you definitely can, and we have done stuff in the past for people that do movie design, where they have their characters, they'll send us the file, we print it out for them. That's definitely feasible.
One of the problems is making file that was STL.
Yeah, STL, there's also a couple other file types that you can use, .stp, .step, .obj. A lot of different 3D models can be used. STL is kind of the easiest one. It's the simplest, it doesn't have as much other information. But if you're curious, if you have a 3D model, you can always try and open it in the program and see if it'll handle it. If you can't, it'll just tell you this file type's not supported.
I used SketchUp for some stuff.
Yeah.
Just before 3D printing, so I'm not sure it's compatible.
You can definitely export to the right thing in SketchUp. SketchUp in particular is a little bit tricky because it's kind of a cross between programs like Fusion and programs like Maya, where you're creating flat surfaces and kind of connecting them together. So usually when you export things from SketchUp, unless you're very careful about it, you're going to run into the same problem as when you make stuff in Maya. So I would always, just to be safe, if you're making something in SketchUp, run it through Mesh Mixer, do the make solid thing anyway, just to be safe.
Is it backwards compatible, so those might back?
Once you save something as an STL, it's difficult to edit it again, unless you already made it in something like Maya, where it's already kind of a mesh as you're editing it, then it's not as bad, but STLs aren't really designed to be edited. They're kind of your end format for printing.
The classes that you mentioned that TerraWorks has, is that open entrepreneurs as well, or is it based on?
So we've had people from outside campus come to us. We're still kind of in the pilot stage for it. So right now it is just open to anybody who wants to come out and do it. A few years down the line, I can't guarantee that's going to be around or what it's exactly going to look like because the university is always changing its policies around regarding people outside the university using stuff. But right now, anybody can come in, anybody can learn.
Is there like an ecosystem around the SQL files?
So, the main thing of like why STL is so popular is there's a couple websites in particular that a lot of people upload their files to share with other people with 3D printers. And basically every file on those websites is an STL. So whoever started those websites just said STL is the preferred format. Everybody went with it, and now since those are like the handful of sites everybody goes to, it's just kind of been adopted. But like in particular, those are things like Thingiverse, My Mini Factory. These are websites that just have a bunch of free and sometimes paid for models that you can go online, download. People have already designed it out and just print it.
Any other questions? Do you teach individual classes or have you actually had people outside who are probably interested?
So I'm a TA on campus for an undergraduate class for people learning 3D design in programs like this. So I teach students there. I also will, like, if somebody shows up to the weekly CAD coaching type stuff, I will typically work one-on-one with whoever it is and kind of figure out exactly what they want to get out of whatever program it is. And if they're trying to learn one program, but they want to do something that will be better in another program, I kind of point them towards that and give them a run doing that. Typically, we have 2 hours per week. If we don't finish everything in the 2 hours, I'll either suggest they come back next week and we'll just pick it up, or I'll give them links to different online videos on YouTube or other free tutorial websites where they can kind of pick up their learning pace wherever.
And just for everyone to know, where's Terrapin Labs located on campus?
So if you go to the University of Maryland, we have a couple different labs on campus. There's 2 main ones though that you'd be interested in. One of them is in the Herbert Ravin Technology Advancement Placement Building. Essentially, it's just TAP. If you Google UMD TAP building, it's going to come up on Google Maps. There's also the A. James Clark building. That's one of the newest buildings. I'm the manager for the lab in that space, so I've been helping to kind of develop that space and put all the resources in there. That space in particular has a lot of our really nice machines. It has workstations that people can come in and use, nice computers, all that kind of stuff. Those are the 2 main buildings you want to look for. But again, our website, terrapinworks.umd.edu, has all of the information about TerrapinWorks as an organization, all of our locations, anything like that, and our email address if you want to ask us more. So I definitely recommend going to the website if you have any further questions, specifically about what we do or how to get in touch with us.
So everyone, give a round of applause. We really appreciate your time, and I know that everyone had a lot of fun just doing putting through demo. So thank you very much again. So everyone, our meetup is over for the night, but we do have just a few announcements. Our anniversary party is coming up on August 24th at the Great Blacks and Wax Museum. It's a mouthful. Great Blacks and Wax Museum. So come out and celebrate 2 years of our meetup in existence. We're gonna have a 1 hour tour of the museum. It starts at 5 promptly. So if you're interested in coming, please RSVP on our meetup page. We'll have food, we'll have drinks, it's gonna be reflected. But if you're interested in actually doing a tour of the museum, which I highly recommend, you wanna be there at 5 o'clock. Okay, bring your friends, bring your coworkers, and just come and celebrate our meetup. Also, next week is gonna be social night, just casual, just gonna hang out, network with some other people. So feel free to come back again, as you know, we're always here every Thursday. We have someone in our midst here, he's the director of the STEM program, and I'm just gonna bring him up here to talk a little bit about it. It's Phil Rogowski. All right, come through, tell us about your organization.
My name is Phil Rogowski. I am the founder and executive director of Maryland STEM Festival, an annual celebration of science, technology, engineering, mathematics. This year will take place October 11th through November 10th, all throughout Maryland, not just one place. And on October 11th, we have an event we're calling STEM Event Color, where it's going to be at Bremen Lane Elementary School, and we're trying to show minority students there's no reason they can't be involved in STEM. And so we'd love to have some people participate in that event. I brought business cards, and we brought students come talk to me. But we'd love to have some of your members here come participate in that event. So obviously, we're here. It'll be a great event. It's from 6 to 7:30. We're gonna have kids from Bremen Lane School and also Amherst Gardens, which is a largely Hispanic school. And there are many events throughout the festival, the 30 days, but really want to look at it tonight and see over here who's helping out.
Okay, so it's a month-long festival.
The event is a whole month long, and there are other events that I'm particularly looking for. People show the kids that they can go into tech and STEM.
Okay, wonderful, thank you. Again, so John is actually in our Slack channel, you can find him JOHN So if you have any other questions about 3D design, printing, prototyping, whatever, reach out to me directly in the Slack channel. And as always, if anybody has any questions, feel free to put it on the Slack channel. Stay up to date with our meetup page, our Facebook page, for any other news. And if any of you guys are interested in actually going to Afrotech, there's a Google scholarship out there. If you're interested, I don't know if you're interested, it's very costly, those flight tickets and the actual conference fees itself. So there's a Google scholarship for those that want to attend. So I'll put that out in the Slack channel for you guys to apply to. So again, we're done for the night. We're going down and going to some Google network. Thank you all so much for coming. It was a great pleasure having you all here today. Have a good night.
Okay, so,